Welcome to my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmapuri. In this video lecture, Thermal Engineering 2, Model 2. The effect of friction on nozzle. When the steam flows through a nozzle, the final velocity of steam for a given pressure drop is reduced due to the following reason: the friction between the nozzle surface and the steam, the internal friction of steam itself, the shock wave or back pressure will be applied. The effect of frictional losses occur between the throat and exit in the convergent and divergent nozzle. The frictional losses entail the following effects: expansion is no more isentropic and enthalpy drop is reduced, so losses the final velocity. The drainage fraction of the steam is increased as the part of kinetic energy gets converted into heat due to friction and absorbed by the steam with increase in enthalpy. The isentropic volume of steam is increased due to frictional reheating. It reduces efficiency of nozzle. If friction is 15%, the efficiency of the nozzle is 80%. Increase the entropy. The figure shows the HS diagram for the isentropic expansion of a steam in a nozzle. Enthalpy vs entropy diagram. The above curve is saturation line. From here the initial pressure P1, the final pressure is P2. From the process A to B, isentropic expansion process, from A to B dash is the actual process. The expansion is no more isentropic and enthalpy drop is reduced, so losses the final velocity. From the y-axis H1 is equal to 40, from H2 is equal to 20. From the isentropic expansion is theoretically it will be happen, means there will be frictional losses will be happen. From the actual process, the H3 is 25. From velocity is equal to 44.72 square root of H1 minus H2, velocity will be decreased, the enthalpy will be increased. Next point, the drainage fraction of the steam is increased as the part of kinetic energy gets converted into heat due to friction and absorbed by steam with increase in enthalpy. From the process A to B dash, it will be happen on the wet region. Wet region means the water droplet is from the steam, the water droplet will be present. From the process from the nozzle, the steam is from the x is equal to 0.96, the drainage fraction. The drainage fraction is improved because of the friction will be happen. The heat will be transferred from the inside the nozzle. The drainage fraction will be improved. The isentropic volume of the steam is increased due to frictional reheating. From the isentropic volume of this frictional reheating, PV generally PV equal to C. The specific volume will be reheating from density 1 by rho equal to specific volume. To reduce the efficiency of the nozzle is the efficiency is 85%. Nozzle efficiency will be from the friction will be happen in the nozzle. The 15% losses will be happen. The final point is increase the entropy. Entropy is nothing but disorder. Disorder will be increased. The efficiency will be decreased. These are all the factors affect from the effect of frictions. From the steam nozzle, from the upper layer, the insulation will be surrounded from the nozzle. The high pressure steam is entered to the nozzle. That will touch on the surface metal or metal surface. The friction will be happen. The heat will be transferred from inside the nozzle only. Automatically the drainage fraction will be improved. The most of the friction occurs in the divergent part of a convergent divergent nozzle, as the length of the convergent part is very small. The effect of friction is to reduce the available enthalpy drop by about 10 to 15%. The velocity of steam will be done. Already I told about you from the convergent divergent nozzle, the divergent part is very small compared to convergent divergent nozzle. The friction will be happen in the throat and convergent and divergent part. Final velocity is equal to 44.72 square root of K H1 minus H2, where K is the coefficient of which allows for friction loss. It is also known as nozzle efficiency. V suffix 2 is equal to square root of 2 H1 minus H2 into nozzle efficiency. Velocity of the steam at nozzle exit V2 square is equal to 2000 into H1 minus H2 plus V1 square. Finally, we get V2 is equal to square root of 2000 H1 minus H2 plus V1 square. As the velocity of steam entering the nozzle is very small, V1 can be neglected. From the divergent part or convergent part, the initial velocity is very small compared to final velocity. That's why we have to neglect the initial velocity. Finally, we get final velocity is equal to square root of 2000 into H1 minus H2. Finally, 44.72 square root of H1 minus H2 meter per second. If the friction losses are taken into account, we have to add the nozzle efficiency. V suffix 2 is equal to 44.72 square root of H1 minus H2 nozzle efficiency. These are all the important factors affect the friction. Entropy is increased. Already I told about the entropy is increased due to the velocity will be decreased, means entropy will be increased. The available energy is decreased. Velocity of the flow at throat is decreased. Volume of flowing steam is decreased. Throat area is necessary to discharge a given mass of steam is increased. Next slide. The topic is the mass of steam discharged through nozzle. Generally, the isentropic process from the nozzle may be expressed PV power n equal to constant, where n is a polytropic index, n is equal to 1.35 for saturated steam. The critical pressure ratio is 0.574. For n equal to 1.3 for superheated steam, the R equal to 0.5437, where n is equal to 1.035 plus 0.1x for wet steam. Work done is equal to n divided by n minus 1 into P1 V1 minus P2 V2 isentropic basic formula. From gain in kinetic energy, the work done during the isentropic process, that is V2 square by 2 into V1 square by 2 equal to n divided by n minus 1 P1 V1 minus P2 V2. V1 can be neglected since V1 is very small, less compared to V2. V2 square by 2 equal to n divided by n minus 1 P1 V1 minus P2 V2. Finally, V2 square by 2 equal to n divided by n minus 1 into 1 minus P2 V2 by P1 V1. We know that P1 V1 power n is equal to P1 V2 power n. Finally, we get the specific volume V2 by V1 is equal to P1 by P2 power of 1 by n. V square by 2 is equal to n divided by n minus 1 P1 V1 1 minus P2 by P1 into P2 by P1 power of minus 1. Here the P1 by P2 is reciprocally, we have to write P2 by P1. Next, n upon n minus 1 P1 V1 1 minus P2 by P1 power of 1 minus 1 by n. Finally, we get V squared by 2 is equal to n divided by n minus 1 P1 V1 1 minus P2 by P1 power of n minus 1 by n. Finally, velocity is equal to 2 into n divided by n minus 1 P1 V1 into 1 minus P2 by P1 power of n minus 1. Finally, we get the velocity is equal to square root of 2 into n divided by n minus 1 P1 V1 into 1 minus P2 by P1 power of n minus 1 upon n. Generally, mass is equal to density into volume by time, density into area into volume. M is equal to AV by specific volume, M is equal to AV by final specific volume. Finally, we get the mass is equal to area by V1 into P2 by P1 power of 1 by n, square root of 2 into n divided by n minus 1 P1 V1 into 1 minus P2 by P1 power of n minus 1 upon n. Finally, we get area by V1 into square root of 2 into n upon n minus 1 P1 V1 into P2 by P1 power of 2 by n minus P2 by P1 power of 2 minus 2 by n into P2 by P1 power of n minus 1 divided by n. Finally, the mass is equal to area by V1 into 2 into n upon n minus 1 P1 V1 into P2 by P1 power of 2 by n minus P2 by P1 power of 2 by n plus n minus 1 by n. Finally, we get m is equal to a divided by V1 square root of 2 into n divided by n minus 1 P1 V1 into P2 by P1 power of 2 by n minus P2 by P1 power of n plus 1 by 2. From the convergent and divergent nozzle, there is a 3-port. First port is convergent port, second port is throat, third port is divergent port. Already I told about the effect of friction will be happen on the throat section and convergent and divergent section from the exit condition of the final velocity. From here, the convergent section, the Mach number is less than 1. From throat section, Mach number equal to 1. From the divergent nozzle, the Mach number is greater than 1. By manipulated, we get m equal to a square root of 2n by n minus 1 into P1 V1 into P2 by P1 power of 2 by n minus P2 by P1 into power of n plus 1 by n. From P1 is initial pressure of steam, P1 is initial specific volume of steam, V1 is velocity of steam of entry, P2 is pressure of steam exit of throat, specific volume of steam at exit or throat, final velocity of steam of exit or throat. A is equal to cross sectional area. Thank you.